August 2025, the North Atlantic looks calm, but a silent alarm flips the map near the Norwegian Sea. Sensors on the USS Gerald R Ford carrier strike group catches a strange underwater pattern, and the room goes cold. This is not a routine shadow. It feels like a probe built to read a carrier's pulse. 3 Russian submarines are believed to be closing in, hunting for acoustic and electronic fingerprints, the kind of data that turns into weapons later. NATO answers with speed and structure, pushing aircraft, ships, and a quiet hunter below the waves into one tight net. What follows is set to be the biggest anti-submarine chase in this theater since the Cold War, where timing, data links, and discipline matter more than tonnage. This story tracks the clash between old wolfpack tricks and a modern sensor web that sees through noise. Stay to the end, because the lesson will shape how fleets move in 2025 and beyond. Like, share, and subscribe to the military force if detailed breakdowns of weapons, tactics, and strategy are your thing. New reports drop fast when the seas heat up. The encounter begins with detection, because first contact sets the tempo for everything that follows. The quiet hunter holds the thread, because a clean trail decides who controls the water. A Virginia-class submarine rides behind the contacts at a measured offset, using its TB-34 towed array to collect faint tonals that do not carry to surface ships. The BQQ-10 suite cross-checks those lines with narrowband libraries and bearing drift, then builds a motion picture instead of a single fix. Pump jet thrust limits cavitation during course changes, while isolation mounts cut machinery hum that could reveal position. The goal is simple: stay unheard, watch every correction, and record how the targets breathe under stress. With the recorder in place, pressure can rise without losing the thread. Trailcraft prefer geometry to drama, since patience beats speed in acoustic combat. The Virginia keeps a constant angle off the target's stern quarter, adjusts depth to dodge layers, and times turns to avoid self-noise spikes. If a boat sprints, the trailer eases power to let the wake settle, then slides back onto the line once the roar fades. If a boat drifts to mask, the trailer nudges deeper to read persistent tones that do not vanish with throttle. Every minute logged becomes a future fingerprint that shortens later searches. With signatures maturing, the surface screen can start to manipulate tempo. Surface combatants simulate pressure without crossing legal lines because control of rhythm breaks a stealth plan. Destroyers angle in as if to launch a weapon, then hold outside release limits while keeping bows pointed down the likely exit path. Helmsmen make steady-rate turns that change the acoustic picture in predictable ways, forcing the contacts to react rather than choose. The British frigate drags its Type 2 087 curtain through key corridors, shaping the options available to any submerged intruder. These maneuvers deny calm, burn stamina, and reveal pilot habits at the helm. With choices narrowing, air power can add a sharper edge. P8. A-crews fly simulated attack runs that trigger defensive routines without firing a shot, because fear of a weapon can be as useful as a weapon. A dive from altitude, a timed descent rate, and a deliberate altitude gate all look like a delivery profile on the scope of a submarine. Operators below must assume danger, so they blow ballast, turn hard, or duck through layers, and each move writes a line the processors can read. After a climb-out, the aircraft resets and repeats with new spacing, so the pattern stays unpredictable. That choreography burns crew focus and battery margins aboard the targets. With stamina draining, the data link can carry richer tracks to every ship in the ring. Psychology meets engineering in this phase because minds crack before hulls do. Submariners work in metal tubes where light is scarce, clocks matter, and alarms echo, so repeated cues wear down judgment. A simulated approach forces fast choices, and fast choices usually print habits onto the water: a preferred rudder angle, a favorite depth band, a telltale throttle step. The trailer reads those habits and updates a playbook that turns uncertainty into forecast. Once a habit is known, a decoy loses value, since the copy cannot fake fatigue. With behavior exposed, tactics can shift from wide nets to precise corrals. High density requires strict deconfliction, because one mistake can break the net. Airspace is stacked by altitude blocks, lateral buffers keep wings apart, and time gates prevent overlapping turns near the same box. Helicopters log hover points and announce dips through agreed phrases, while ships publish sector limits and maintain minimum closest point of approach under standing rules. Channel plans keep national radios from stepping on each other, and data links move updates without long voice calls. Safety officers watch fuel, weather, and sea state to protect crews while tempo stays high. With order intact, pressure can increase without adding risk. The Virginia benefits from that order, since clear lanes let a stealth trail keep contact during complex maneuvers. When a destroyer swings to block, the submarine holds the shadow with tiny power changes and small planes, keeping the towed array outside turbulent water. When helicopters dip through a thermal layer, the trailer notes how the target shifts trim to resist the ping field. When an aircraft hints at a drop, the trailer watches for reflexive dives that mark nerves rather than plans. Each instance strengthens the model that predicts where the target will turn under strain. With prediction overtaking reaction, the initiative belongs to the coalition. Endurance management closes the loop because pressure fails if the hunters tire first. Crew swaps on patrol aircraft, scheduled quiet windows for hull sonars, and smart routes that avoid heavy chop keep sensors honest. Ashore support moves parts and fuel forward, while maintenance teams rotate to keep platforms on station. The Virginia's reactor gives weeks of energy, yet the limiting factor is crew focus, so task cycles balance watch intensity with recovery. Commanders judge success by denial of clean recordings rather than dramatic strikes, since information denied today saves lives tomorrow. With the trail firm and the adversary worn down, the scene is ready for the 48-hour endgame where withdrawal or exposure becomes the only choice. Command turns fast when the picture hardens, so NATO shifts from awareness to action. Arleigh Burke destroyers swing to cut the approach lanes, while a British Type 23 pushes south to anchor a barrier on the carrier's flank. P8. A Poseidon's lift from Norway, Scotland, and Iceland in staggered waves, because spacing beats hurry when geometry matters. Each launch widens coverage, and each orbit trims blind spots without wasting fuel. The aim is simple: box the contacts and force choices. That posture only works if command and control stay tight from the first call to the last ping. Control starts with clean lanes, because safe airspace keeps sensors alive. The airborne controller divides the sky into blocks by height and grid, with P8A at altitude and MH60R below 500 feet. Horizontal buffers prevent crossing beams, and timing rules keep turns predictable during handoffs. Ships hold assigned sectors and help request moves before leaving boxes, which keeps everyone inside a known plan. Frequencies split by nation reduce crosstalk, while standard brevity shortens calls under pressure. With the lanes set, the net can form without collisions or radio clutter. Fusion makes the lanes useful, since isolated tiles do not make a map. Northwood Center pulls feeds from radar, electronic support, sonobuoys, hull sonars, and towed arrays into one layered display. Algorithms weigh track quality, merge duplicates, and tag confidence so crews trust the picture. Bearing-only lines turn into fixes once arrival times align across multiple ears. Operators see altitude, speed, and trend arrows, not just dots, which turns noise into behavior. With a live 3D battle space, commanders can assign roles by effect, not guesswork, and timing becomes a tool instead of a worry. The mission for this phase is fix and hold, because pressure requires position. Destroyers shift to barrier geometry, pointing bows toward likely escape axes while keeping torpedo lines clear. Type 23 drags. Type 2087 towed array to extend the listening curtain, and Burke crews stream AN/SQR-19 while SQS-53C manages active pulses when needed. P8 lays boxing patterns with calibrated spacing, using different buoy types to blend passive detection and active confirmation. Math drives every drop, since range rings decide whether a contact becomes a firm plot. Once fixes harden, movement narrows, and planning can add measured force without losing safety margins. Helicopters add the close hand, but they do it with discipline. MH-60R teams lower dipping sonar through thermal layers, sample bearings, then hop to the next hover point to avoid patterns the target can read. Crews carry lightweight torpedoes to preserve deterrence, yet the focus stays on tracking rather than shots. Nation-by-nation channel plans prevent stepped-on calls, and data links push updates without long voice traffic. The net tightens by rhythm, not volume, which helps crews preserve fuel, hours, and attention. As coverage thickens at low level, fixed-wing sensors can widen search arcs without opening seams. Sustainment keeps the plan alive, because fatigue breaks nets before tactics do. P8. A rotations maintain fresh crews and constant orbits, while deck cycles on surface ships align with quiet periods to avoid gaps. Weather cells and sea state get baked into routes so sensors keep range without flirting with risk. Fuel plans and spare parts sit forward, and relief schedules arrive before concentration slips. Commanders judge success by denial, not fireworks, since a clean library for the adversary would pay off for years. With contact constrained and the rhythm set, the force is ready to open the full sonar web and strip away every decoy. The layered sonar net is built to box a contact and hold it, because shape and timing beat speed underwater. P8. A crews lay sonobuoys in a tight, boxing pattern, spacing each drop by plan, not guesswork, so coverage overlaps without waste. Passive DIFAR buoys listen for narrowband tones and blade rates, while active diecast buoys ping to force a clear echo when doubt remains. Each buoy reports bearing, strength, and health, and the aircraft updates spacing as winds and currents drift the field. When ranges close, the crew seeds a second ring to tighten the grid, and the contact finds fewer paths out of the box. With the surface map forming, heavier sensors can push the net wider without opening a hole for escape. Surface combatants add depth and reach, since a fleet's ears grow longer when steel moves in the right geometry. Hull-mounted sonar paints the near water with controlled pulses, shaping the contact's choices and measuring close turns with steady timing. Towed arrays trail far behind the wake, listening in quiet water where prop noise fades and distant tonals carry. Triangulation turns bearing-only lines into position when three platforms hold firm sectors, and false lines drop as math beats rumor. Commanders steer bows toward likely axes, so torpedo arcs stay clear and dead zones shrink in front of the screen. As the grid hardens at range, vertical gaps matter more than horizontal seams. MH-60R fills those vertical gaps because a dipping head can punch through layers that bend sound. Crews hover low, lower the AQS-22, sample bearings across depths, then climb and slide a short leg to a new point to avoid patterns. Thermoclines that once hid boats now become markers, since cross-layer samples expose changes that static sensors miss. Helos push updates over the data link, so every ear in the force hears the same plot within seconds. Short hover cycles save fuel and reduce risk, while staggered positions keep 2 or more cones on the target volume. With the columns sampled, processors can read behavior, not just noise. Discrimination follows, and this is where modern processing breaks the old tricks. Decoys show odd Doppler, unstable tonals, or canned modulation that fails under cross-check, while real boats carry steady machinery lines and shaft rates that move with load. Multi-sensor correlation looks at time of arrival across buoys, helos, and ships, then assigns a confidence score that rises as physics agrees. Machine-aided filters trim sea life, wave slap, and ship traffic without deleting faint submarine cues. False alarms waste fuel and focus, so thresholds shift with sea state and traffic to hold quality above quantity. With the trash cleared, the plot gains weight, and every minute of clean data sharpens the hold. Wolfpack tactics unravel under that weight, because noise is a poor shield when many ears compare notes. One submarine climbs to mid-depth and thrashes to distract, but multi-static pings show the real movers below as coherent, steady diamonds. A sprint leaves cavitation that rings across ranges, and a drift exposes minute course tweaks that match a known class signature. Thermal layers once bent sound away, yet dipping cycles read through them and show the boat paying a tax in speed for a short blind. The more the formation maneuvers, the more its rhythm appears on the board as a pattern that can be predicted. With deception stripped, only endurance and crew discipline remain as shields. Sustainment keeps pressure honest, because a net frays when crews tire and batteries die. P8. A rotations refresh orbits. Buoy health is tracked like fuel, and recovery plans replace weak nodes before gaps appear. Ships rotate active pulses to manage marine safety and keep the water readable, while arrays stay quiet enough to hear far. Hello teams cycle through brief deck turns, and maintenance windows align with low-risk periods so the picture never goes dark. Fix and hold is the scorecard, not spectacle, since denial of a clean recording hurts the enemy longer than a loud splash. With the web tight and the track stable, the stage is set for the silent hunter to press closer without giving itself away. The silent trailer holds the key, because control of the trail decides control of the fight. A Virginia-class submarine sits offset behind the contacts, using its TB-34 towed array to hear faint tonals that surface ships cannot separate from wave noise. The BQQ-10 suite cleans those lines, compares them with narrowband libraries, and turns bearing drift into a living motion picture. Pump jet thrust reduces cavitation during small course changes, while quiet mounts keep machinery hum off the water. The task is to stay unheard while logging how the targets steer under stress, and that setup lets pressure build without losing contact. Trailcraft choose geometry over drama, because steady angles beat raw speed underwater. The Virginia holds a constant position off the stern quarter, trims depth to ride under thermoclines, and times turns to avoid self-noise spikes. If a submarine sprints, the trailer eases power, lets the wake settle, and slides back when the roar fades. If the target drifts to mask, the trailer shifts depth to catch machinery lines that do not vanish with throttle. Every minute becomes a future fingerprint that shortens the next search, so patience turns into leverage for the wider force. Surface ships add tempo without crossing legal lines because rhythm shapes choices. Arleigh Burke destroyers angle bows toward likely exits, signal a weapon profile, and then hold outside release limits to avoid escalation. A British Type 23 pulls its Type 2087 towed array through choke points, stretching the listening curtain across escape corridors. Helmsmen keep steady rate turns, so processors can read true reactions rather than noise artifacts. Those moves deny calm, burn stamina, and reveal helmsman habits the library can store, which is how surface posture feeds the underwater trail. Air power sharpens that posture, because a false strike run forces real defensive routines. P8. A crews dive from altitude at timed rates that mirror delivery profiles, hold a gate, and climb out before any release point. Operators below must assume danger, so they blow ballast, kick hard rudder, or duck through layers, and each choice prints a curve the network can map. Crews repeat with shifted spacing so the pattern stays fresh and the battery plan breaks. The payoff is a richer track with behavior tags, and those tags make the coalition's timing more exact in each follow-on pass. Psychology meets engineering at this stage, because minds crack before metal does. Life in a steel tube is ruled by clocks, alarms, and thin margins, so repeated cues wear down judgment and dull fine motor control. Fatigue brings shortcuts. The same rudder angle in a hurry, the same depth band under stress, the same throttle step when ping fields rise. The Virginia watches for those tells and updates a forecast that can predict the next turn within a narrow arc. Once behavior is forecastable, decoys lose value, and the net can shift from wide search to guided corralling. High density demands strict deconfliction, because a single mistake can break the web. Airspace is stacked by altitude, lateral buffers separate wings, and time gates stop overlapping turns inside the same box. MH-60R crews announce dips with standard calls, ships publish sector limits and closest point of approach rules, and data links move updates without long voice traffic. With the trailer firm, the rhythm steady, and the picture shared, the coalition owns initiative, and that ownership sets up the 48-hour conclusion that forced the northern withdrawal. The endgame is clear. After nearly 48 hours under steady pressure, 3 Russian submarines turn north and end the intelligence run. NATO keeps distance while maintaining contact quality, holding firm plots until the tracks fade past the barrier line and risk drops to routine. Acoustic teams catalog shaft rates, pump cycles, and rudder habits, then align them with timestamps to build reliable motion scripts for future hunts. Electronic support units log emission timing and beam patterns, creating an EM profile that shows how crews manage posture under stress and silence. These acoustic/EM fingerprints flow into allied libraries, which shorten search time, reduce false alarms, and lift identification confidence across the GI-UK-Norwegian corridor. A tighter library means faster queuing for P-8A or MH-60R, better geometry for destroyer screens, and cleaner handoffs inside multinational command nets. The strategic effect is deterrence by competence, since an adversary that cannot harvest a clean carrier pulse must design weapons around gaps and guesses. The legal and political record also strengthens, because logs, tapes, and link tracks align, leaving little room for spin and lowering escalation risk. Doctrine hardens as well. Barrier geometry improves. Buoy spacing adapts to currents, and hover cycles read through layers without burning fuel or attention. Industry absorbs lessons into software and simulators, while forward logistics align parts, crews, and weather windows to sustain long sorties in rough water. All of this proves a simple rule with modern weight. Network beats platform when time is short and seas are busy. With the probe denied and the database enriched, the narrative moves toward a measured conclusion that explains how information now writes control at sea. Modern anti-sub warfare is no longer a duel of single ships, because networked sensors and disciplined control now decide outcomes. This fight showed how a fused picture turns noise into behavior, and how behavior can be managed without crossing red lines. The side that moves data faster gains time to maneuver, and time to maneuver keeps flight decks and crews safe under pressure. Russia must cut signatures, rethink decoys, and learn to cross thermal layers without leaving clear traces. NATO will push AI for acoustic sorting, expand UAV and USV patrols, and keep joint drills tight so handoffs stay clean. Deterrence grows when logs, tapes, and tracks align, since proof makes quiet power speak louder than headlines. The North Atlantic will favor the fleet that reads early and acts in rhythm, while old reconnaissance habits keep failing in hours, not weeks. That is the practical lesson of this chase, and it will shape the next contact long before it starts. Like, share, and subscribe to Military Force for clear maps, real numbers, and sharp breakdowns of weapons and strategy.